Hello, welcome back. So in lecture 1, we're going to introduce some general concepts in computer science. So we're going to define what is computer and what is information. We're also going to discuss a little bit about the history of the computers and also the categories of computers and some applications of computers. So after this lecture, you will be able to identify what is computer, and you'll be able to define what is information and how to measure the information, how to transfer the information. You will also be able to compare the different types of computer, and you will know the usage of computers in our daily life. So first of all, let me ask you a question. So what exactly is computer? So you probably will say, okay, the computers must be is those type of machines. We can use the machines to do a lot of stuff. And let me show you an image. So this image is from 1949. It's from NASA, from the Dryden Flight Research Center. So you can see those are the early computers at work. So actually, at that time, computers were human. There's even a book named When Computers Were Human. So it discussed, talks about the stories when the computers were human, and a group of people will do the computation work. So I don't know why all the computers are women. So probably women were good at mathematics, so they had a lot of computers to do the work. Of course, those are not the computers we are going to discuss in this class. So what is computer? So this is a computer. Of course, this is a desktop, and this is a laptop. It's also a computer. And this is the like a mainframe, the supercomputer. Here are some tablets, some smartphones, some like PlayStations, even the calculator. We can think this one as a computer. So out of this are computers, and I think it's easy to understand these are computers. But how about those ones? Like I showed you some images here. These are also computers. Like the leftmost one is the is the Google Glass. So it's also a small intelligence computer inside of it. And next one is the projector. So you can see the keyboard there, and below it is a computer used by military machines. And then we have the at the bottom of the image is the smartphone, a smartwatch. So it's also a computer. And in the middle is the world's first robot citizen. It's called Fiona. So all of these are also computers, right? So if I ask you to give me a definition of the computers, we should find something in common for all of these machines, right? So we have to define what is the common features and the common components of all of these machines. So what is a computer? First of all, it's an electronic device. Must be some electronic devices that can do the computation. So they operate under the control of stored instructions. So we are going to discuss about what is the instructions later. And it can accept input, and then it can process the input and generate some output. So this is the computer. So we use this one as the definition of the computer. So you can see the image here. So we have some input here, and then we have a machine, electronic device. The device will process the input, and then it will generate the output. So how do the machine process the information, process the input? It uses a program. So this is the definition of the computer. If we define an abstract structure of the computer, it looks like this. So it's actually defined by John von Neumann, who is a mathematician, So this is the structure of the modern computers. We can see there are basically 5 different components. We have the input device, output device, secondary storage, primary memory, and then the central process unit. And inside the central process unit, we have ALU, which is the arithmetic logic unit, and the control unit. So this is the structure of the computer, and we are going to discuss this structure in the hardware lecture also. So what is computer? So data stored into a computer is called the input, and the process result are called the output. So the cycle of input, process, output, and storage is called the information processing cycle. So this is a cycle. We have input here, and then we process the input, and you can generate some output, and at the same time you can store the information somewhere, and then you can, by communication, you can send to the input again. So this is the computer. So here we have a concept. We have a new concept is called information, because this cycle is called information processing cycle. So what is information? Here are some images from 1940s. At those time, the raw materials lay all around in the landscape of that time. So the data actually transferred through post mails, through broadcast newspapers, telephone, television, advertisement, movie posters. So you can see the data there. But are all those informations? And what's the common property or features behind all of those different type of data? So one young scientist called Claude Shannon started to thinking about this, the common features or properties behind the different forms of the data. So he said, I have been working on analysis of some of the fundamental properties of general systems for the transmission of the intelligence. So he used intelligence to represent, this data, and then he talked to his colleague to use the word to define this concept, and his colleague said that intelligence is kind of like an old word, so you probably can use something new. So they used the word information. So Claude Shannon actually defined a theory called the information theory, and he thinks the information is about off and on. So it's like on and off. So basically you have 2 different status. So information theory made a bridge between the information and the uncertainty between the information and the entropy, between the information and the chaos. So what is uncertainty? Why the information is about uncertainty? Because if something, from my understanding, if something is certain, there is less information, right? Like if I say, okay, so today's weather is pretty good, so there's not too much information because it is the good weather today. But if I say tomorrow's weather will be, maybe tomorrow will be raining, so that can give you more information because it's uncertain. So the information is really about uncertainty. So uncertainty can also be called as the entropy. So entropy is an important concept in the information theory. So we use entropy to define how uncertain the system is. So the fundamental problem of the information, first of all, is how to define the information, and how to measure the information, and how to transfer and store the information. And how to measure the information, Claude Shannon defined a unit. It's called a bit. Okay, bit. So he used the bit to measure the information. It's like how large or how small, how much or how less the information is. So they use bit. So in the third chapter, we are going to discuss how to represent information using binary. And actually, bit is the smallest unit in binary. So we actually use bit to measure the information. And how to transfer and communicate the information, we can use a system called communication system. So in the communication system, we have like a point. At one point, you can like send out the information and then use some kind of channel to transfer the information. And then at the other side, you can replay the information. It's called the information transformation or communication. So how do we transfer information? So the most easiest way is to use the human being to transfer the information. So you probably know the story of Marathon. A runner runs 26 miles back from the plain of Marathon to Athens, bring the news of the Athenian victory over the Persians. And he died of exhaustion, right? So, like if he had WeChat at that time, he can just send a message and it will not be necessary to run for such a long distance, right? But anyway, unfortunately, the technology wasn't ready at that time. Okay, so except using the human being to transfer the information, we can also use light to transfer the information, right? So when you see the image of smoke, you can probably guess somewhere get a fire, right? So it'll be more efficient to transfer the information. But without the background information, we probably don't know what exactly happens. But if you see a picture like this, you probably can know much more information. So this is a picture of the Great Wall, and you can see some smoke from the watchtower. So in the ancient time, if there are some, if someone sees the smoke from the watchtower, that means enemy comes. But this way is more efficient compared with the human delivery, right? But the problem for this one is that it's not that expressive. So there are some enemy, but you don't know how many of them, right? So it is still not the perfect way. Okay, so except using the human light, we can also use the sound. You can use the sound to transfer the information. So when you hear something like this, okay, so what that means, that means something. And what about this? Okay, so actually the two sounds have two different meaning. The first one means you should get up. This is the sound in the Chinese military. So when you hear this sound, it means you have to get up. And the second sound means you have to go to sleep. So we can use the sound to transfer the information, right? And what else? Except the human being, we can use light. We can also use audio. We can also use electricity, right? We can use the electricity to transfer the information, and that will be much more efficient compared with this ways. So that's why we have the telephone. So why we call it telephone, because you use the electricity to transfer the information. And the telephone in Chinese is called 电话. Okay, 电 means electricity. So actually, we can use the electricity to control it, to make it on and off. to transfer the information. So that's the concept of information. So in next video, we are going to discuss about the categories of the computer.